Oh, this question is, when we look at it, we might not clearly be able to deduce how to proceed with it. This is a daunting looking question. So we'll start with. So first, observe that A is, or rather, we can write the numerator as 281 times 7 plus 6 iota sine theta. The denominator obviously 7 minus 3 iota cos theta for theta in R. This is A. So now we have slightly better looking numerator and denominator. And yeah, for this to be a positive integer, we'll first multiply by the conjugate of the denominator to get and in the denominator we'll be left with 7 square is 49 plus 3 cos theta square is 9 cos square theta. So now for this to be a positive integer, we'll need that the complex part from this turns out to be 0. So let's start. Deal with this part separately. Multiplying these two brackets, we'll get 7 into 7, that is 49. First we'll write the real part. So 6 iota sin theta times 3 iota cos theta will become minus 18 sin theta cos theta. Plus the imaginary part will be 3 iota cos theta times 7 and 6 iota sin theta times 7. So that will be 7 into 3 times 2 sin theta. So this is our numerator, 281 times this whole thing, and the denominator we have 49 plus 9 cos square theta. Now this to be a positive integer, we need this part to be 0. That gives us tan theta is minus half. That gives us 281 times 49 minus 18 sin theta cos theta. So one of the values will be cos theta equals to 2 by root 5, sin theta equals to minus 1 by root 5, or the negative of them both, but that won't matter because anyway sin theta and cos theta multiplied, so we'll have the net result would be a negative, and in the denominator cos square theta is squared, so it won't matter. We take cos theta as plus or minus 2 by root 5. So let's take these two values. So we'll have 49 minus 18 times sin theta into cos theta simply becomes 2 by root 5 into minus 1 by root 5, and in the denominator we'll get so this whole part will become 0 by design, and the denominator we'll have 49 plus 9 times cos square theta, that becomes 4 by 5. So this is 281 times 49 plus 36 by 5. So 2 into minus 1 is minus 2, minus 2 times minus 18 is 36, and root 5 times root 5 is 5. And in the denominator we'll have 49 plus 9 4s are 36 by 5. So this whole thing gets cancelled and we are left with the answer 281. So n is the only positive integer in the set A and it is 281.